And the next session here is a panel discussion on AI and supply chain from silicon to shelf in the age of intelligent infrastructure. And let me introduce the moderator over here, and our panelists will be introduced by him, Yash Hemaraj, and he is the partner with BGV Ventures. So I'll let the team here take it from here. And again, once again, thank you so much, everyone.
Thank you, everybody. So my name is Yash Hemaraj. I'm a general partner at BGV. BGV is Benhamou Global Ventures. We are an early-stage enterprise software investment firm based in Menlo Park. We invest in companies that are born globally, innovation hubs such as Israel, France, India, etc. And we help them make a transition to the US markets and then global markets. All of us have been on the operating side, so we try to help them, take venture back to its roots, where you actually roll up your sleeves and work with the founders. So that's been our DNA. And we have multiple pockets of capital. We have a pre-seed vehicle called Arca Venture Labs, where we invest in Indian founders in the pre-seed and seed stages. We have a Series A vehicle where we invest at the Series A stage, $2 to $4 million checks, and then we invest from our opportunity funds at much later stages. With that introduction, we have a very interesting topic here on hand. So we're going to talk a lot about, we're going to cover a lot of different topics today, ranging from delivery systems, safety, a lot of real use cases. So thank you, Joydeep, for that wonderful session, because you set up the stage very, very well for the discussion that we'll have right now. We have assembled a panel of experts, each of whom are not only experts in their own field, but they're all cross-functional experts. I'm going to ask each of you to introduce yourself, and then we're going to dive in.
Hi, good afternoon, everyone. I'm Nihaar Mahatme. I'm a Director of Technology Strategy at NXP Semiconductors. We are a company that mostly builds embedded chipsets for automotive, industrial, IoT applications. So within our team, we identify the hardest challenges when it comes to building more power efficient, more secure chips with greater intelligence embedded in them. My own background is device engineering, circuit design for aerospace applications. I've been with the company for about 9 years. I'm based in Austin, Texas. And yeah, looking forward to talking to you guys today.
Hi, my name is Sujit Sharan, and I work for Intel. I'm a fellow in the Advanced Design Technology Solutions group at Intel, and we chiefly are working on nowadays at the leading edge of trying to integrate as much of the silicon as possible into different package configurations, especially advanced package configurations, because one of the topics that will come up during the discussion would be around how do you make your systems more resilient in the supply chain, and how do you get different pieces to talk to each other. And that's where we have been doing a lot of work, working with both EDA vendors and within our own design environments to develop solutions which allow us to integrate a lot of heterogeneous pieces of silicon into one coherent whole. So that is one of the leading advances that we have been working on, and that's some of the stuff that we are driving within Intel in my group.
Right. So firstly, I'm very happy to be here at TiEcon 2025, and thank you for the invitation, and quite honored to be here on the panel talking about supply chain and manufacturing, unpacking that a little bit. So my name is Venkatesh. I am the VP of Supply Chain at Diamond Foundry. Diamond Foundry is a global startup. We are headquartered here in the Bay Area, but we have operations in the United States and in Spain. And as it's very evident in our name, we do work with we work with diamonds. So we are in the domain of lab-grown diamonds. We are one of the largest in the world. And when you think in terms of diamonds, think not just in terms of just growing them and having them in jewelry applications, but think of now diamonds, interestingly, in a whole variety of high-tech applications. So think of diamond as almost like a heat spreader for chips, which are doing AI running models. Think of diamonds in power electronics, switching, and think of think of diamonds in a variety of niche telecom and defense applications. My background, this is a little bit about the company, but my background's, I'm an engineer by training, but I spent all my life in supply chain in a variety of companies, from automotive to consumer electronics, and in large companies and in startups. So very happy to be here again and unpack manufacturing at the panel over here.
Thank you. Like I mentioned, we have very cross-functional experts here. Maybe I'll start with you and maybe talk about what are some macroeconomic trends that you're seeing in your industry, and maybe we'll expand that into some of the use cases.
Okay. So to go back to the question, essentially what we're seeing is a lot of separation between in the industry, in that you have a lot of things going on the client side of things, where you look for smaller, thinner chips. You're looking at things that are much more power sensitive and drive a lot of the innovations from a different side of things, which is a lower power, thinner packages, smaller form factors, and so on and so forth. The other space, which is in the high-performance computing and the AI side of things, which is where a lot of the action has been of late, is integrating as much silicon as possible into the package from heterogeneous sources. When I say heterogeneous, I mean both from a node perspective, which is that you look at an n-2, n-1, and n nodes in the package, but also across, and we see that in Intel, obviously, a lot of the products are coming in where you have pieces of silicon from different foundries, which are integrated, both internal foundry as well as external foundries being integrated into the same package. What we are looking at, and since I come in Intel, I work for developing design and strategies and architectures for packages, we are looking at it from the perspective of being able to homogeneously bring all of these pieces together into extremely large packages and have them communicate with each other, talk to each other, and work as a holistic whole, driving both from a power and performance perspective. So we do see a natural split happening in this, and especially on the consumer space and in the client space, going small, cheap, and thin. And in the AI space, that's where you are pushing the power demand, you're pushing all of the, we talked about Diamond Foundry, and Diamond as a heat spreader would be something which would be very, very interesting, because thermals is going to be a huge deal with some of these packages. So that's where we see Intel going and spreading.
Do you want to add?
Yeah, so I'll come at it from a different perspective, not generally industry perspective, but the macro trend is very obvious to all of us here, right? I think 2, 3 macro trends, but they culminate in making this a bit of a tumultuous world, right? But I think 3 factors or 3 vectors in which I think about the world, which is you're looking at transformative policies. Think of deglobalization primarily as one. You're thinking of transformative technologies. Think of AI. And I also think that we are living in a very manifestly capable world. So there are capabilities which are spread out all throughout the world, and never ever in the humankind have each of us been so capable, right? So I think those 3 are kind of, think of it as macro trends, but how does that impact us in the space of supply chain, right? So effectively what we are saying is we want to have things made locally in our backyard. We want to have things made cheap at low cost with high feature sets, and we're trying to have this done in no time, right? So one illustrative example of how this impacts supply chain, I would say, and manufacturing, is that automation is no longer a background thought, for example, right? It is front and center automation first world in which I think we're going to be operating now going on future, right? So something that allows you, whenever, for example, we internally at the company think of building processes, we are always taking an automation first approach to it, right? So when we talk to machine builders, we are almost always talking about how can you automate this. It can be so that the process is fail-safe, it can scale in no time, and it is still nimble and adaptable. So all those automation-rich feature sets are, in my opinion, going to be front and center now, and just not for process and manufacturing operations, but also back-end and warehouse management and all the other varieties of operations. So yeah, that's just, supply chain is a big spectrum, So there's one idea of in that spectrum. Yeah.
Do you want to add?
Yeah, just to add to the previous speakers, translating the work that we do, the technologies that we build into actually products that we can put into our hands of our customers is extremely important. A low-hanging fruit that AI that we've seen address across industry verticals is actually demand forecasting, sales forecasting, which is not as trivial as you think in this global situation where you have a lot of different macroeconomic trends, a lot of different factors, interdependencies, trade, tariffs, location of developing things. So thinking about what sort of user preferences our products will resonate with is a complex challenge. And when the variables start exceeding 50 or 100 in number, AI or models are your only friend in trying to detect what is the best product that your customers eventually consume. But that's an area where I think AI is inherently well suited to sort of address and solve, because it is able to scale and deal with multivariate problems and provide solutions that our customers are looking for. So that's an increasing trend that we see where AI is increasingly being used in the semiconductor industry as well as in many others. Specifically speaking about NXP and the challenges we face, we build systems that need to be robust, fail-safe, reliable, for automotive, for avionics, for industrial systems. These things need to function 24/7 for years together in the field, like talk about smart grid or a car. Essentially, you're putting people's lives at risk, right? So relying on AI algorithms that by nature do have some probabilistic aspect to them, which they may not produce the correct output, does have risk associated with it. So we're always constantly battling between how do we ensure reliable operation while still deploying the latest and greatest AI algorithms at the edge and provide correct solutions to our customers.
A lot of very interesting thoughts there. I mean, no doubt AI is a force multiplier, and thanks to the billions of dollars that has been invested in the foundational layers as well as the infrastructure layer, this is kind of, provides the utility on top of which we can build application. Right? I mean, a lot of the use cases that you just spoke about. But I think the beauty of making these systems work is how do you tie it to those individual use cases and make the AI part invisible, and also bring the right data into the mix, right? So that's where some really good opportunities to build some very interesting companies. So that's what we are seeing, and we are kind of funding some of these companies which come with founders with this idea, with very detailed understanding of those workflows. And then how AI can kind of get embedded and actually made invisible so that you can actually focus on the value, right? So really interesting opportunities here. So maybe we'll kind of go deeper into the semiconductor innovations, because a big part of where we are today has been enabled by some of the innovations that's going on in the semi space. So maybe can you double click on some of the innovations in the semiconductor space?
We can start. If you look at the classic supply chain problem, right, especially when it comes to compute, data and information is moving everywhere all the time. So a big challenge that we see from many of our customers is they want information to be consumed and available locally and very quickly. So an inherent problem with cloud... Oh, I'm sorry, I'm not very close, but... Anyways, the inherent problem with any supply chain is moving data, moving information, moving products and goods around. So if you think of compute, whether you're using cloud or a server, there's information flowing from a chip, from a device somewhere, through cellular networks, through optical fibers, through satellites, through Ethernet, internet, to different locations and back. So there's inherent risks in doing something like that from a security standpoint, from an intrusion standpoint. Many customers also care about real-time information being available very close to the source. Think of large factories, machines, cars that need information in millisecond or nanosecond timescales. So the latency of communicating with the cloud, communicating with servers is simply not acceptable. So a lot of the solutions that we're developing for the edge, because they consume data very locally, process information locally, inherently reduce that attack surface from a security standpoint. So that's a key concern many corporations have and are building even private networks now to keep information on-prem, protected, data leakage, data theft is a big concern that almost everyone cares about today. So edge computing is, sort of well positioned to address that, whether it's AI or just information in general.
Yeah, no, definitely. AI at the edge is a very, very interesting canvas to work on, and a lot of challenges there, and a lot of companies that are being built out there. So, very interesting. Sujit, and thank you.
So, just to pick up on the themes that we are talking about, the speaker before us, he was talking about something which was very interesting, and we are looking at that very, very carefully. It's all about the data. It's all about moving things. Being able to manufacture things faster means that you have to get data in and out a lot faster. Talked about digital twins. Digital twins is, he said it, I really concur with that, that's the future. The ability to be able to replicate your entire manufacturing line digitally is of critical importance. Right now, we are getting there, but we are very much in the infancy stage where you still, and a lot of engineers feel that, hey, till I see it actually in the lab, I'm not going to believe it. So you will run your models, but you would still tend to say, okay, I do need to validate it. I think we are coming to a point, though, where the crossover is happening where we should be, and we are able to replicate a large part of the entire, all the way from a design space. So before I start design, we can do everything on digitally, do the design, run it through the line virtually, and have a digital product at the end which you validate. And then you just use that to essentially set your line free. And that, I think, is going to be extremely critical. And that requires a lot of AI prowess. Obviously, a lot of advances in AI. It requires a lot of compute. It requires a huge amount of data movement. And I think that's where a lot of the gains in the semiconductor industry especially are going to come from, is being able to drive things away from the physical world into the digital world and get all your validation in the digital world. And I think the silicon guys have been doing that for a long time. The EDA vendors have been doing a lot of these things where you do all of your modeling, you do everything, you do your multi-physics models and get everything in space. But this is the entire manufacturing line being digitally replicated. That, I think, is a big innovation that is going to happen, and it's moving really fast. The other piece, which is, again, goes back to, you talked about the latency piece of it, which is also what we see now is people want to, and high bandwidth memory is becoming a big growth for all of the memory vendors, is putting as much memory as possible in as close a proximity to the compute tile as possible. And that is where we are seeing a lot of the innovations with 3D architectures, with stacking, heterogeneous, both in the, you do both a lateral as well as a vertical stacking, and that's where we see a lot of the physical innovations coming in, where Intel has a new technology with embedded bridge that we are driving. There are, competing technologies outside of Intel from TSMC and from other vendors, which are essentially achieving the same thing, is putting the latency, drive the latency down, get your memory, get your compute tiles, your I/O tiles, everything talking to each other much faster and much closer. So overall, I would say, hey, we need to move things, validate everything digitally, because you can't afford to, it's too expensive and too time consuming to manufacture and run pilot lines. Run the pilot line virtually, and obviously use all of the resources that you have to drive latency down, to drive compute up, drive power and thermals down.
No, very interesting. We invest in AI systems, right? And I think most of the enterprises, when they look at using AI, I think the opportunity is when you look at it from a systems with like end-to-end feedback loops, et cetera. And one thing that we see differently with AI systems is that they're not going to be built like SaaS companies. SaaS was the previous wave. The new wave of AI companies are not going to look like SaaS companies. And the important aspect is data, because if you want to derive insights from for AI, you need that data mobility, and the data has to be at the edge. You cannot ask enterprises to give your data to an external vendor. So the whole deployment model is going to change with the new wave of AI native companies. Venkatesh, do you want to add?
Yeah, I think, so I'm not a technologist by training, but I'm going to touch on a couple of things that were already mentioned here, right? So, Yash, you mentioned about how do you deploy, how do you make your systems or subsystems talk to each other, and how do you extract value from it effectively, right? So an illustration of that, right, one from back in the day and one that we do today is interesting, right? I used to work for a company, we were doing early AI ML, I'm talking about 8 years back, and it was in the consumer space. So we used to build smart ovens effectively, right? So you put whatever food it's in there, the camera is in there, it'll detect what's the count of the food, what type of food it is it done yet or not, does it need to be toasted, for example, how does your bacon need to be cooked, right? And how many pieces are there, how thick is there, how chewy should it be, etc. But using that basic AI primitive kind of, I'm talking about 8 years back, so basic knowledge of AI ML, we were able to predict that and translate that into a pleasant experience for the customer. But a customer can't be waiting around, latency is unaffordable in those applications. They want instant gratification, right? Now take that same concept over the years now in a completely different application like what we do within our company, right? Mm-hmm. So the process of growing a diamond as an illustration, right, takes some time, right? It takes a few days, multiple days, right? And by the way of, and this is AI ML in action, right? So by rigging our tools with a bunch of sensors and a bunch of images, right, from cameras, continuous feed, we are able to detect what specific recipes are leading to the maximum efficiencies, right? Within this given recipe, are there certain areas within the growth pattern which are doing very well and which are not doing very well, mm-hmm. right? And all of this is of course generating tons and tons of data, the data we own, and a lot of data analysis goes behind that. But the net result of all this is that it really, the gap between ideation to execution is really shortened now, mm-hmm. right? So we are able to capture those advantages in almost no time and innovate and reduce costs and pass those benefits on to our customers. So it's happening in real time, it's real, right?
All right. Now we'll stay with you and kind of maybe switch topics a little bit, right? Because I believe if you're in TiE, you have to discuss global innovation, right? When we started off the talk, we spoke about macroeconomic disruptions, and a lot of that is in the supply chain, thanks to tariffs and trade wars and geopolitical instability, etc. So in the semiconductor industry, maybe you can start and talk about, what are some global innovation, maybe you can talk about various geographies and what are some innovations that we are seeing globally?
So it's it's on top of mind, all of us, what tariffs is doing. Don't look at tariffs as an isolation. So if you look at last 10 years in supply chain, we've had at least 2-3 disruptions come in, right? We had the tariffs first come in 2018. A lot of us moved operations out of a certain country. I did that, right? Mm-hmm. Then we had COVID, which disrupted supply chain and completely distorted demand and supply of goods and services. That lasted for about a couple of years. Then right now we have another tariff challenge in front of us. I think it's very clear that one philosophy to take out of this is that you have to maintain a supply chain local to the area of your operation. Mm-hmm. So I think that's becoming a requirement, and that's what we are seeing within our company for sure. Outside of that, I would say that generally there are many, the innovation hubs so far in Semicon have been isolated to a few geographies, right? Mm-hmm. So think of Far East for foundries. Think of a lot of OSATs, which is outsourced supply, semiconductor assembly and testing. A lot of that is in Malaysia and in Taiwan and those regions. We have a lot of machine builders, and all the equipment suppliers are concentrated by and large in the European region, a lot of them. So I think as the world gets deglobalized and as a lot of CHIPS Act money for the US and for the Europe gets spent, you will see a lot of capacities and capabilities being created locally. And it's not just having a factory over here, it's also having a lot of the ecosystem that goes around with here. Right? So if we set up a factory, do we make the machines that go into the factory locally? Do we make the tools that go into those machines locally? Mm-hmm. Do we make the testing equipment that gets built locally, right? A lot of that is going to happen, and I think it's an interesting time. We will see how all that transfers effectively across geographies, but I think one thing is for sure that capital formation is going to increase very quickly, and it's a huge opportunity, right?
Sujit, your thoughts on global innovation?
Yeah, so just to pick up on what you're saying, ideally, we see this happening is that you see things trying to move locally, but especially in the semiconductor industry, the costs are prohibitive. I mean, it's not. A fab is a multi-billion-dollar investment. It's not that you're going to just pick up a site and go. It's having the right technology, the right engineering support systems, which gets critical. I mean, we're talking in TiE here. I mean, especially on the semiconductor manufacturing side, design, a lot far easier, which is why you see design houses spread a lot more globally than what you see manufacturing spread. Manufacturing becoming much more expensive, especially the silicon side of things. Assembly, you're seeing the Far East. I mean, India is making a big move in the assembly, starting in assembly. They are setting up some packaging houses and packaging manufacturing sites in India, but chiefly concentrated in the Far East. Mm-hmm. Silicon side of things, because of the cost, and then again, obviously, the drive for localization drives things pretty much US, Europe, a little bit in the Taiwan with TSMC. But the big issue, I think, is going to be is how do you get your costs in control, because the financing of this is going to become very critical. I mean, it's not that you can just pick up and set the 2-nanometer fab somewhere and have it up and running shortly. So from the way I look at it is there will always be globalization. People, because you do want to go, cost is a huge imperative. You want to manufacture at the lowest cost. And so the globalization, I mean, there will be efforts to deglobalize, but I don't think it's something that's you're going to just shut off and have everything be localized. I don't think that's going to happen. I think there will still be a fairly well interconnected world, and we will continue. There will be efforts to make sure that you have multiple sources, not necessarily local, but you'll have multiple sources so that you're not tied to any one geography.
But for the founders who are building new companies, the opportunities, you say, are in assembly, design, and packaging.
Yes, I would think so.
Right.
I think silicon gets, I mean, you would work on the, older nodes. That's a little bit easier, but then that's almost entirely cost-driven. Mm-hmm. The higher nodes, it's far more difficult to break in.
Thank you. And Nihaar, anything you want to add to that?
Yeah, I'll just add that, for founders or larger companies, the key thing is to identify your innovation and differentiation and maintain that, right? That can be a natural barrier to any obstacles like trade and tariff that could put into place. Like the world today is an information highway. Information flows freely, products can flow freely. You can also set up fabs in different locations. There's no physical barriers to that, but knowledge is very local, right? It resides in classrooms, it resides in labs, it resides in cafeterias where people exchange tribal knowledge that has been acquired for years and years that is not easy to replace. So if you look at that as your value creation and differentiation, there are pockets of centers of excellence that can be created. Like you look at football or musical instruments, cloth manufacturing. This has been around for decades, but why do we see the best footballers from Brazil or best musicians from Austria or the finest carpets from Iran? These have survived years of trade, tariff, invasions, and have yet maintained their quality and excellence, right? So the key is, I think, for new startups or founders is to identify their differentiation and build a moat around it, which can withstand trade and tariffs, because you simply don't have a technology that replaces you.
So the name of the game is resiliency. Thank you for some wonderful comments. Thank you so much, and thanks for TiE for such a wonderful conference. Thanks for bringing us all together. Thanks for being here, and thank you, my fellow panelists, for a wonderful discussion. I really appreciate it.